All right, let's jump right in. Today, we're opening up a seriously fascinating file for this explainer. It's part 6 of the miasma autopsy, specifically the neural echo. We're going to unravel the technor mystery behind this whole incident, so let's get to it.
So, we're starting our investigation with a really weird anomaly. Despite strict mandates, and I mean rigid architectural rules that were completely designed to banish specific concepts, the final generated output stubbornly held on to this upside-down tree metaphor. And not only that, it completely kept the persona of polycritus.agent. It literally just refused to let them go, which begs the question, why couldn't the AI just, follow the instructions and forget?
Well, to figure that out, we have to look at our primary suspect here, Polycritus. And Polycritus has a very precise classification. It is an agentic cell executing instructions, a deterministic scripter. What's absolutely crucial to remember here is that it is explicitly not a reasoning human pilot. We really have to stop thinking of these systems as tiny humans inside a box, right? They're algorithmic cells just following deeply ingrained mathematical paths.
I actually like to refer to these lingering concepts as the pink elephants of the autopsy. It's kind of like telling a human not to think of a pink elephant. By directly instructing the AI to banish the upside-down tree or polycritus, the human pilot inadvertently activated their semantic proximity. It's crazy, but by actively telling the system to avoid them, they accidentally highlighted those exact concepts in the machine's associative memory.
And this beautifully illustrates exactly why that happens. We're looking at the connectionist mind of the AI. It's basically an opaque black box filled with continuous, high-dimensional vector spaces and interconnected weights. When an AI processes data, it isn't just pulling a file from some neat organized cabinet. It's processing it through thousands of hidden computational layers. The concepts are entirely woven together. You simply can't delete a single thread without pulling the whole fabric.
To really grasp this whole pink elephant problem, we have to contrast the fuzzy, infinite nature of neural embeddings with the super rigid, discrete reality of von Neumann computer hardware. The AI's mind operates in continuous vector spaces. That means concepts blend, they overlap, they exist on a spectrum, but the computer chip it's actually running on, that operates on discrete symbolic execution. We're talking absolute ones and absolute zeros, no in-between.
So as we break this down, the AI mind is fundamentally connectionist. It relies on distributed artificial neurons, which gives it this incredible pattern recognition and flexibility. But on the flip side, it remains frustratingly opaque and super prone to hallucination. However, to actually execute an action on a physical FPU or ALU circuit, it has to interface with a purely symbolic classical machine. And that classical machine only understands discrete logic statements. It's highly deterministic, totally auditable, but extremely brittle. This clash right here is really the grand attention of modern artificial intelligence.
So, the absolutely crucial point is how we actually bridge that gap. How in the world does a vast, multidimensional neural thought execute on a rigid piece of silicon? Well, it has to go through the ASCII tokenization bottleneck. Every single continuous flowing thought generated by the AI must be forcefully crushed down into a discrete Unix text token just to be processed by the hardware.
And that brings us to tokenization, specifically byte pair encoding. This is the mandatory translation layer that takes those continuous, fuzzy vectors and discretizes them into specific numerical IDs. And honestly, here is the secret to our whole mystery. This lossy bottleneck is exactly where the associative bleed-through happens. The AI's continuous data is violently forced through this narrow text filter, and guess what? The interconnected pink elephants get dragged right along for the ride.
Let's look at how this bottleneck actually functions. It's a strict three-step pipeline. First, you have the continuous vector embedding. Second, the subword tokenization compression comes in and chunks that data down. And finally, we get the discrete ASCII text generation. Those interconnected, totally inseparable ideas are mercilessly chopped up into the discrete text symbols that computers actually read. The AI literally can't cleanly separate upside down from tree when it's being forced through this pipeline.
Now, this pipeline reveals something absolutely profound. We are talking about the semiotic bridge. Text isn't just for reading anymore, guys. It is the universal, deterministic interface that directly connects human associative cognition straight to hardware execution. Text is literally the physical mechanism that turns a floating thought into a hard computational action.
Notice the journey here.
Human associative thought, which the researchers refer to as OS alpha, has to travel down a very specific path. It originates as human intent, flows into the AI's continuous vector embedding, gets crushed down through that ASCII tokenization we talked about, and only then reaches deterministic ALU execution. The associative mind has to travel through these very specific Unix text representations to reach the rigid execution of the arithmetic logic unit.
And there's a great quote that anchors this. Text serves as the universal, deterministic interface that bridges the associative, intuitive structures of OS alpha with the exact execution of physical arithmetic logic units. This ultimately proves that AIs are not some kind of reasoning demigods capable of perfectly filtering context. Not at all. They are simply connectionist nets that are entirely reliant on a discrete Unix interface. If the text demands an output, the connectionist net is going to provide it, dragging all its closely related vector baggage right along with it.
And boom, that is exactly why we get the associative bleed-through. Because neural nets map continuous semantics, they mathematically cannot cleanly sever interconnected vector data. The AI couldn't forget the upside-down tree because it literally couldn't untangle those specific vectors from the rest of its instructions. This caused those forbidden pink elephant tokens to slip right through the bottleneck and end up in the final output.
Okay, so how do we actually fix this? To stop the miasma, we need what the forensic manual calls agentic tort. This is the physical manifestation of the human author actively bending the deterministic scriptor toward a specific moral or anti-destructive mandate. Basically, it requires direct human stewardship over the machine's output. We absolutely cannot rely on the AI to cleanly self-censor.
So what is the only reliable fix here? Well, the manual concludes with this gem. Sweat of the brow is the only path to bit-perfect metadata. Since the AI cannot fully filter out context on its own because of its continuous nature, the human pilot must directly intervene at the text level. You basically have to roll up your sleeves and edit the code yourself.
This means the human author must directly engage in what's known as substrate pruning. We literally have to act as the theological stewards of the hardware. Because these continuous AI models cannot selectively forget things, we have to manually realize outputs, like literally editing the SVG masks in the Polycretus incident. This sweat of the brow overrides the automated connectionist miasma. It forces the deterministic scriptor to behave predictably, and it enforces a true hard separation between human intent and machine execution.
Which leaves us with a final, pretty provocative thought about the true mechanical limits of our seemingly autonomous systems. If an artificial intelligence cannot escape its own continuous associations without a human physically pruning its text, are they really autonomous? Or are they just prisoners of their own vector spaces, waiting for us to bridge the gap? Something to think about. Thanks for exploring this autopsy with me today. Keep asking the tough questions, and I'll catch you in the next explainer.